Hi everyone. Now in this lecture we will discuss very important STL container that's called a map, and I will explain with the help of one example. And suppose what you do when you visit a restaurant or a canteen, you generally ask for price of a food item. Okay, so let's say you go to your college canteen and you ask the owner what is the price of, let's say, a Maggie. Okay, and he says okay, it's 20 rupees. You make certain other queries as well. Okay, what is the price of juice? He says okay, 25. You also ask okay, what is the price of, let's say, Pepsi? And he says okay, this is 35. Okay, so what happens, you give certain inputs. Okay, so these are called keys, and for each key there is a mapped value. Okay, so this is the value map. Okay, so sometimes in real life we might need to store data in the form of key value pairs, and this is where the map comes into a picture. Okay, so a map is a associative container that stores mapping between key and the value pairs. Okay, so in C++ it offers you two types of maps. One is called a simple map, and there is another kind of map which we will discuss later on, that's called unordered map. Okay, so the goal of the map is to store this mapping, key and the value mapping. Okay, so the main thing is, you can, what are the main operations you can do? You can insert a key value pair. Okay, you can say store this item. Okay, you can query, which means you can search okay, what is the price of this particular key. And you can also delete. Okay, suppose Mag is not in the stock and you want to remove this item from the map. Okay, and this is you can give okay, delete or erase this particular key. Okay, and there are corresponding function in STL. So insert function is written as insert, query function can be done using find function, and delete can be done using erase function. Okay, so let's have a look how to use different methods to work with the map. And one more thing, how does this happens internally? Okay, so a map maintains a self-balancing BST to do the work. Okay, and one special thing about the map is keys are ordered. Okay, all the objects are ordered according to the keys. Okay, so storage happens in this manner. For example, you insert these fruits, Maggie, juice and Pepsi, and let's say M comes before, oh, okay, M comes after J. So maybe this is where the juice would be, this is where the Maggie would be, and this is where it would be the Pepsi. Okay, and it would be a self-balancing BST, and ordering is defined by the key. Okay, so keys are ordered in maps, and in our unordered maps the keys are not ordered. Okay, so let's see the implementation now. Okay, to include the map data structure, you have to include the header file called hash include map, and after that you have to create a map object, and that map object should be given what is the data type of key and the value. For example, let's say key is the string and int is the value, and let's call this object as M. Okay, let me also include the string header file. Okay, okay, so what I'm going to do, and let us try to insert few objects in the map. So you can say okay, m dot insert, and this insert function takes a pair as a argument. Okay, so what you can do, you can say okay, make pair of, let's say, mango and 100. Okay, this is the fruit and this is the price. So there are multiple ways to insert in the map. One is using the insert function, another is you can also create a pair. You can say a pair of string int p, and this is p dot first equals to apple, and you can say p dot second equals to 120, and you can say okay, m dot insert p. This is another thing that you can do. Okay, so this is how you can insert using this method. Second way to insert is you can also say m of banana equals to 20. Okay, so this will actually create this particular key banana, and this will make the value equal to 20. This is another way to insert inside the map. Okay, and let's say you want to search for an element, if an element is present in the map or not. So let's see how you can do the search. And suppose you know the key, you ask the user, okay, give me the key, let's say string key, and you say scene key, or whatever is the fruit name, you can just take that input from the user. And now to search, you can use either the find function. Okay, so what we can do is we can say, okay, auto it equals to m dot find, and I give the fruit. Okay, so this find function will return an iterator to the fruit node. Okay, and I can say if it is not equal to m dot end, which means the fruit is present inside the map. In that case, you can just say, okay, price of fruit is this much. Okay, and this price can be given by m of fruit. So you can use the direct excess operator, m of fruit. Okay, what's there in map of banana. Okay, so that will give you the price. Else you can say this particular fruit is not present. See out fruit is not present. Okay, so let's try to run this much code, and let me give you a key called, let's say, banana. Okay, K says fruit is not present because we are using a capital B here, so this should be a capital B here as well. Okay, or you can convert the input into a lowercase, and everything can be stored in lowercase also. Okay, okay. In the meanwhile, let's also see another way to find a particular key. Okay, so map has a special property that it stores unique keys only once, which means a key can be stored only once. That means if you now do m of banana equals to 40 or something like that, the old value of the banana will be updated. Okay, so if you do m of banana equals to 40 now, it will not create a new key, it will update the value of the old key. Okay, so unique keys are stored only once. And what we can do is we can use a function called count to check if a key is present inside the map or not. So this is an alternative to the find function. So I can say if m dot count of whatever is the fruit. Okay, so this count function actually returns an integer. It will return 0 or 1. 0 means this particular key is not present, and 1 means this particular key is present. So I can say, okay, if this key is present inside the map, so you can say, okay, price of this fruit is m of fruit. Okay, else you can say cout could not find this fruit. Okay, so let's try to run the code, and this will work in a similar manner as the find function. The only difference is the find function returns an iterator, and the count function returns an integer. Okay, so this returns a iterator, and if you want to know what is the data type of iterator, so it's very simple. It's built inside the map class. So this will be written as, if you want to replace auto with the data type, so the data type will be map of string int colon colon iterator. Okay, so this is how you define the data type of the iterator for the map. So from both the statements we get the price of banana is 20, and let's now try to erase this particular object. Okay, so let's see how we can erase. If I say, okay, m dot erase this particular key or this particular fruit, so that will delete the corresponding key value pair from the map. Okay, so earlier price of banana is 20, but once we deleted the map, once we deleted the object using the erase function, we could not find that particular fruit inside the map. Okay, let's do one more thing. Let's try to update the price. Okay, let's try to update the price. So maybe we can say it's quite easy actually. Okay, so before finding, what we can do, uh, let's say m of fruit plus equals to 20. Okay, so earlier price is 20, we are adding let's say 22 in it. This will actually update the price of banana. Okay, and another thing that we can do is iterate over all the key value pairs. So just to show you the result, I'm adding 2 3 more keys. Let's say m of lychee equals to 60 and m of let's say pineapple equals to 80, and let's try to iterate over all the key value pairs. So I can say for auto uh, it equals to m dot begin, it not equals to m dot end, it plus plus. Okay, so when you're using an iterator, and this iterator is going to point to a node that is going to store both key and the value. Okay, and if you want to access the key from it, you have to do it like this. You have to do star it dot first, because this is a pair object. Okay, and or you get to do star it dot second to get the value. Okay, or another notation that you can use is you can use it arrow first to get the key, and you can use it arrow second to get the value. Okay, this is what you can do. So let's try to print all the key value pairs that are present in the map. So see out it arrow first, and let's say this is the value, it arrow second, and followed by handle here. Okay, so let's run the code and see if we are able to iterate over all the elements of the map. And we can also use a for each loop to iterate over all the elements, and you can see we are able to iterate over all the elements of the map, and they are in sorted order. And let's also just make this as capital L and capital P, so you can see the keys are sorted lexicographically. Okay, so for each loop, for I can say auto, a pair P that is there inside the map M, I can say C out P dot first and P dot second. Okay, maybe colon P dot second. Okay, so you can also use a for each loop to traverse the map. Okay, so you can see apple followed by lychee followed by mango and pineapple, and all of these keys are in the lexicographically sorted order. Okay, so this is about the basics of map STL, and we will discuss some more use cases in the coming videos. Thanks a lot. See you guys in the next tutorial.